Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. In small office and home office (SOHO) environments, proper IP configuration is the foundation for all network communication. Whether connecting a laptop to the internet, assigning a fixed address to a printer, or troubleshooting connectivity problems, a solid understanding of how IP addressing works is essential. SOHO IP configuration involves assigning or obtaining an IP address, defining subnet masks and default gateways, and ensuring proper DNS resolution. The A+ exam places strong emphasis on these fundamental topics, which are also among the most commonly encountered issues in day-to-day IT support. A static IP address is manually assigned to a device rather than obtained from a DHCP server. This address does not change unless it is manually reconfigured, making static IP ideal for devices that need to be consistently reachable, such as printers, file servers, routers, or surveillance cameras. Along with the IP address, the user must also configure the subnet mask, default gateway, and DNS servers. This approach provides predictability and reliability, but requires more hands-on management, especially as the network scales. To assign a static IP on a Windows client, a technician must access the network adapter's properties through the control panel or settings menu. Once inside the adapter settings, they can manually enter the desired IPv4 address, subnet mask, default gateway, and preferred DNS server. It is crucial that this information is entered accurately. Misconfigured static IPs, such as incorrect subnet masks or gateways, can result in partial or total loss of connectivity. Technicians must also ensure that the static IPs lies outside the DHCP range to prevent address conflicts. Dynamic IP addressing, handled by the Dynamic Host Configuration Protocol (DHCP), automatically provides devices with valid IP configuration details. DHCP assigns an IP address from a defined pool known as a scope, along with a subnet mask, gateway, and DNS settings. This automation dramatically reduces administrative overhead and supports mobile or temporary devices that don't need fixed addresses. In most SOHO networks, DHCP is enabled by default on consumer-grade routers and serves the majority of client devices. Comparing static and dynamic assignment helps clarify their use cases. Static IPs are reliable and easy to locate but must be manually documented and maintained. Dynamic addressing offers flexibility and is ideal for general users and short-term connections. Many networks combine both strategies through DHCP reservations, which ensure that specific devices always receive the same IP from the DHCP server. This allows consistency while still leveraging the convenience of automated address delivery. The default gateway is a critical part of IP configuration. It defines the IP address of the router that handles traffic destined for other networks, such as internet-bound traffic. In most SOHO environments, the default gateway is the LAN address of the router, typically 192.168.1.1 or 192.168.0.1. If the gateway is configured incorrectly or omitted, devices may be able to communicate locally but will fail to reach external resources like websites or remote servers. Subnet masks are used to differentiate the network portion of an IP address from the host portion. For example, the subnet mask 255.255.255.0 indicates a Class C network with up to 254 usable host addresses. This is common in SOHO environments, where a single subnet typically serves all connected devices. Misconfigured subnet masks can cause devices to believe that other systems are outside their network, even when they are not, resulting in failed communications and confusing troubleshooting scenarios. DNS, or Domain Name System, allows users to reach websites and internal network resources using human-readable names rather than IP addresses. DNS servers can be specified manually in the IP configuration or automatically assigned by the DHCP server. SOHO routers often use the ISP's DNS servers or forward queries to public DNS providers like Google or Cloudflare. If the DNS server address is incorrect or unreachable, users may report that they cannot browse websites even though basic connectivity is still functional. When DHCP fails, devices rely on a fallback known as automatic private IP addressing, APIPA. This feature assigns an IP address from the 169.254.0.0/16 range when no DHCP server is available. While APIPA enables limited communication with other APIPA-configured devices on the same network segment, it does not allow Internet access because no default gateway is provided. Recognizing an APIPA address is a strong indicator that DHCP has failed or been blocked by a switch or firewall rule. APIPA addresses are easy to recognize. They always begin with 169.254 and lack a configured default gateway. These addresses are automatically assigned by the operating system when a DHCP request times out without receiving a response. If a device shows a 169.254 address, it means the system was unable to contact a DHCP server. This may indicate a physical disconnection, DHCP server failure, or a misconfigured switch blocking DHCP traffic. APIPA is useful for local troubleshooting and peer-to-peer communication, but offers no route to the Internet or other networks. When faced with IP configuration issues, a methodical troubleshooting approach is essential. Start by checking the physical connection confirm that Ethernet cables are securely plugged in or that the wireless connection is active. Next, verify the adapter's configuration using tools like ipconfig on Windows or ifconfig on Linux and macOS. These utilities display current IP settings, including IP address, subnet mask, gateway, and DNS servers. If the IP address is invalid or expired, commands like ipconfig/release followed by ipconfig/renew may re-establish connectivity with the DHCP server. A DHCP reservation is a powerful feature that allows a DHCP server to assign the same IP address to a specific device every time it connects. This is done by linking the IP to the device's MAC address within the router or DHCP server configuration. This hybrid model combines the manageability of DHCP with the consistency of static IPs. Printers, IP phones, and other devices that benefit from having a fixed IP can be configured this way, avoiding manual entry and reducing the risk of address conflicts. Network Address Translation, or NAT, is a core function in most SOHO routers. NAT enables multiple devices on a private network to share a single public IP address for outbound Internet traffic. When a device inside the LAN makes a request to the Internet, the router modifies the source IP in the packet to its own public IP and keeps a table to track the response. NAT is transparent to internal devices but is essential for allowing home and office networks to communicate with the wider Internet while conserving public address space. Avoiding IP address conflicts is crucial in environments using both static and dynamic addressing. Assigning a static IP within the DHCP range can lead to duplication if the DHCP server assigns that address to another client. This results in intermittent or total loss of connectivity, and operating systems may display conflict warnings. To prevent this, static addresses should be assigned outside the DHCP scope, and DHCP reservations should be used when fixed assignments are required for critical devices. The DHCP scope is the range of IP addresses a DHCP server is authorized to distribute. Scope settings also include exclusions reserved addresses that should never be assigned, and lease duration, which defines how long an address is valid before it must be renewed. Additional options such as default gateway, DNS server, and domain name suffixes can also be configured within the scope. In SOHO environments, these settings are typically accessed through the router's administrative interface. Most SOHO routers provide a web-based configuration interface accessible through a standard IP address like 192.168.0.1 or 192.168.1.1. Through this interface, administrators can view and modify DHCP scope settings, configure NAT rules, manage wireless settings, and implement security features like firewall rules and MAC filtering. Although the exact layout varies by manufacturer, familiarity with this interface is critical for setting up and maintaining functional networks in home and small office environments. MAC filtering is a basic access control feature available on many routers. It allows the administrator to specify which devices are allowed or denied access to the network based on their MAC addresses. When used in conjunction with DHCP, MAC filtering can prevent unauthorized devices from receiving an IP address, effectively blocking them from the network. While not a substitute for stronger security methods like WPA3, MAC filtering can provide a useful layer of control in controlled environments. The ability to release and renew an IP address from the operating system is a vital troubleshooting step. On Windows systems, the ipconfig/release command drops the current IP lease, while ipconfig/renew requests a new one from the DHCP server. These commands help resolve issues related to expired leases, invalid configurations, or stale settings that persist after network changes. Technicians should know how to use these commands effectively and interpret the results to determine whether the client has successfully reconnected. In summary, SOHO IP configuration involves managing static and dynamic IP addressing, configuring gateways and DNS settings, recognizing fallback mechanisms like APIPA, and avoiding common pitfalls like IP conflicts and misconfigured subnets. Whether troubleshooting network issues or setting up a new device, technicians must understand how each piece fits into the broader configuration puzzle. The A+ exam regularly includes questions about these concepts, making fluency in IP addressing a must for certification and practical field support alike. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.